really kind of started growing with Shibboleth, some of the use cases we currently use, and what are next steps. So Vault as a service is provided by the Identity and Access Management team, which is located in a unit called Infrastructure and Communication Technology in UF IT. We're basically the unit that provides all the infrastructure pieces, whether private hosting on our VMware clusters or public cloud deployments in Azure, AWS, or GCP. I manage two teams, and one of them is the Identity and Access Management team, which has 7 systems administrators. Grant is one of them. And we make Vault as a service available to all UFIT units right now. And that is about 7 or 8 units. So that includes research, computing, academic technology, and so on and so forth. The IMT manages the infrastructure, all the VMs that provide Vault, all the backend dependencies for it, and also all the configuration for Vault. We also review and approve all the policies and the roles that teams submit. Right now, we have most of our deployment in the Vault open source, and we're migrating to Vault Enterprise. So we're still using that concept of just one namespace, and Grant will touch on that later. And finally, the IM team is the one responsible for any incidents or issues. We have on-call rotation. So if anyone cannot access Vault, or if we see an increase in, for example, auth logs where we have some Vault agents that are pinging our Vault in a abnormal way, generating a lot of traffic, we're responsible for the incident response as well as the investigation for that. The history of Vault in UFIT kind of started with us adopting infrastructure as code, and specifically Terraform. In 2017, we kind of started with one Windows server with Vault on it, and we're at the tail end of deploying VMs using infrastructure as code, and we're doing Power CLI and then trying to move to Terraform. It wasn't really that developed until in 2018, where the University of Florida IT decided that we need to review our Shibboleth deployment, which is our IDP for all SSO. And we want to rebuild it in a much more resilient way using containerized approach. And that one, the secrets management came into play. And especially when you talk about automation, end-to-end automation, it forces that consistency and repetition. How do we handle secrets there? So after in 2018, that project was completed, we used Vault open source for that. In 2019, we started seeing a lot of cloud deployment requests, specifically in Azure and AWS and GCP. So we followed the cloud adoption framework, and we had the cloud enablement team created. And similar to the approach we took on premises, Terraform was chosen as the declarative language to use for deploying resources instead of learning CloudFormation and Azure RM and Power CLI internally. And all of that work kind of pushed us naturally into a GitOps framework where we use GitLab as our version control, source control system, and use GitLab CI also for pushing those changes to whatever cloud we're deploying to, private or public. We completed all of our Azure GCP configuration with Vault there in 2020. And then we realized that now we're big enough that we need features that are not available in open source, namely the namespaces feature, where we remove ourselves as the policeman in the teams sending us like role requests and policy requests, etc., and give a much more self-service experience to all of our teams. Next, I will hand it over to Grant. They will take us specifically and dive in depth into how we use Vault and specifically the Big Bang moment of Shibboleth and the use of Vault.
Hello. So yeah, Like many of you, we use Shibboleth as our primary SSO identity provider. And as Mehdi mentioned before, we had an initiative to containerize our Shibboleth deployment. And like that mainly spun out of reliability concerns as well as a desire to create flexibility on where we ended up deploying our IDP clusters, whether that be local infrastructure or one of the many cloud providers. We wanted the ability to build these container images, perform automated tests on them, deploy them to a variety of environments, and store them in a registry where we could quickly and easily roll back if any of the clusters had a problem. Obviously, we didn't want to bake secrets and environment-specific configs into these container images. So the solution that we came up with was Vault with console as a storage backend and key value store, and then using console template for building shibboleth config files. We built two main CI/CD pipelines in Jenkins to build, test, and then using Ansible for orchestration, deploy to our various environment shibboleth IDP clusters. I can walk you through those two pipelines. Let's start with the shibboleth build stage. So first, we grab the base TAPS shibboleth images from the Ncommon registry. We then inject template files, the console template binary, the console template config file, and any of our custom shibboleth configuration files that do not contain any secrets or are not environment specific. Next, our next Jenkins will use its own Vault app role that we defined to pull console Vault credentials that have console/Vault policies scoped specifically to the Shibboleth test environment. With those specific credentials stored in the Jenkins workspace, it will then spin up the containers which are configured to run console template on startup before any other shibboleth services are started. Once the container is up and running, we run a series of automated tests. These cover everything we could think of from guaranteeing file permissions are what are expected to actually authenticating through Shibboleth with a test account. When all the tests have completed and passed, Jenkins will then publish the modified container to our internal GitLab registry and then, alert us saying that everything was good. So moving on to the deploy stage. Our Shibboleth IDP clusters are built on a series of Linux VMs. So one at a time, we will put each of these VMs in the cluster in downtime inside our monitoring system. And then just like in the build pipeline, Jenkins will use its Vault app role to pull console/Vault credentials that are specific to whatever Shibboleth environment we are deploying to. Um, but instead of keeping them in the Jenkins workspace, we'll actually be pushing them to the Linux VMs through Ansible. Jenkins will then leverage Ansible again to pull specific versions of the Shibboleth container images. For example, with production, we would be pulling the latest version that has been verified in our beta environment. Jenkins will then spin up the newly pulled containers, which are, as I mentioned before, configured to run console template on startup. Then we will run through what is essentially the same set of automated tests that we used in the build pipeline. If all of these tests pass, then we remove the monitoring downtime from the node that we've been working on, then repeat all of these steps through iterating through all the nodes in the cluster. Once all the nodes are complete, we will run through authentication related tests again, but against the load balancer's virtual IP. Yeah, we wanted to give you a brief summary of our current use cases, which we have listed on the left, before diving deeper into some of them, as well as show all the ways that Vault can be used, which you can see on the right in the diagram that we borrowed from the Hashicorp documentation. Obviously, one of the most common, but possibly least interesting use cases is the Vault key value store. We essentially built a kind of folder structure inside the KB that's split between teams and services. This allows the teams to, easily create policies that are scoped to, whether it be a team or a services space. And then the rest of these we'll dive into in the following slides. So yeah, starting with policy management workflow, as Mehdi touched on here, we manage all of our Vault configuration policies through a GitLab repository that has Terraform definitions in it. And we leverage the Vault Terraform provider. And then when someone needs to make changes or define new policy inside of Vault, they will check out this repository, then they will create a new Git branch. They'll make all their necessary changes inside that branch. Then they push that branch back to GitLab and generate a merge request to merge it back into the main branch. At this point, a GitLab CI/CD pipeline will trigger where things like Terraform syntax checking will verify everything looks good. It'll do a Terraform plan to make sure that there's no obvious Terraform gotchas that we'll run into. And as long as those check out green, we'll actually see that inside the merge request. Then once the once the merge request is created and everything looks good, the IAM team is notified, and the first available person on the team will review the changes inside the merge request. The main thing we're looking for is that no one is essentially growing policy scope larger than they really need. And also, like ensuring that things that do not need like write capabilities don't have write capabilities and so forth. If needed, we'll pull in approvers from other teams if there is something that does kind of grow out of a team's normal scope space. But yeah, in general, we usually do most of the review ourselves. Once approved, the IAM team member will merge the branch back into the main branch. This will kick off another GitLab CI/CD pipeline that goes through the same testing, but finishes off with a Terraform deploy command run. And that's what actually ends up applying the configuration / policy changes to our Vault instance. On the far right, on the far right, we do have a screenshot of the general structure of that Terraform repository. Yeah, CI/CD pipelines are one of our biggest uses for Vault. We leverage the GitLab JWT auth engine in Vault to apply Vault policy for specific GitLab projects at like their CI/CD job runtime. The pipelines then have the ability to pull whatever secrets are needed for the job, and it's also like lets it censor any values that are in the logs. Previously, we handled CI/CD secrets using the GitLab CI/CD variable settings for the project. And this was problematic because we anyone who had admin rights to a project could then go and view these secrets at any time they want, and there was no audit trail showing when they were accessed and by whom. Um, SSL certificate lifecycle is another big use case for us. The uh, Another team actually ended up building out a GitLab project where using YAML files, any other team could define and manage their needed SSL certificates, automating the generation and renewal of said certificates. Anyone could create a new merge request inside this repo, defining new certificates inside the YAML, including a variety of settings, including things like alternative names. Then once approved and merged, a CI/CD pipeline would use the Let's Encrypt API to generate or renew certificates. And it would also handle making any kind of like DNS records that are necessary for Let's Encrypt to verify DNS ownership. Then it would take these new certificates, including any chains, private keys, CSRs, whatever, and push them into Vault, where each team then has their own paths and policies. Then the teams could use whatever method works best for them to deploy the certificates to whatever service, whether that be through a Vault agent install, console template like I covered with Shibboleth, or just any other CI/CD pipelines that leverage something like Ansible for orchestration. Um, SSH authentication is something that we more recently started doing with new Linux host deployments. We started leveraging a cloud init configuration during the Terraform deploy stages that will configure the host to include any necessary user counts and configure it to trust Vault signed client certificates for SSH. We built a custom tool called VSSH, which is really just a wrapper for OpenSSH, where a user will just need to authenticate to Vault using the Vault CLI tool, then run VSSH, whatever user at whatever host, and VSSH will handle the communication with Vault to grab a signed certificate and then pass that along to OpenSSH for client authentication to the remote host. This means that we no longer have admins that are regularly SSHing into servers as root. Um, and admins also no longer need to memorize the root passwords because, yeah, sorry. Yeah, no longer need to memorize the root passwords, and there is a central auditable trail of when someone logged in, and also by having MFA authentication at the Vault layer, this now basically requires MFA authentication to SSH into Linux hosts. Service accounts. So Active Directory is a big one where we already are using the Vault AD secrets engine for automating password rotation for many AD service accounts. And we're currently working on policies and procedures that will essentially require all new service accounts to be managed by Vault. And we'll be able to then take those policies to start updating the old existing accounts as well. For cloud deployments, where we have a lot of people across campus that are leveraging cloud services for a variety of different things, we didn't want people using their normal or even like their privileged access accounts for directly deploying resources to these various cloud offerings. The primary concern being generating large bills without realizing what they were doing. So we handle the resource provisioning through GitLab CI/CD pipelines that leverage Vault to generate temporary service principals with specific roles in whichever environment, and that's what's used to deploy the predefined resources. Then, once the deployment's complete, the temporary service principal is removed. So what's next for us? Big focus is on migrating away from the Vault open source implementation we have over to Vault Enterprise. We're validating a lot of the policy and procedure plans that we have, specifically with namespaces. We want to make sure that they will work in like an actual real world use. We definitely want each team to have their own namespace and associated Terraform repository, but we are still testing out exactly how we want to handle the service spaces. We also want to migrate away from the AD secrets engine to the LDAP secrets engine. The primary motivator here is really just the AD engine is being deprecated. So then we are also working with other teams to expand our usage of the various database secrets engines. Our big use cases being MSSQL and MySQL, but are actively working on integrations with others such as like Snowflake and PostgreSQL. Uh, we want to ensure, or sorry, we want to expand the use of account libraries so that teams and services can manage slash check out a set of credentials instead of dealing with individual accounts for everything. We want to migrate away from our current certificate lifecycle GitLab project that was mostly spun up because of like time concerns, and we were able to get it working with Let's Encrypt pretty quickly. Uh, but with Let's Encrypt, we had to deal with the whole DNS verification, and what we want to migrate to is in-common SSL signed certificates through their Acme service and actually have Vault directly handling all of that. This will simplify, so it'll simplify a lot of things, and yeah, then we won't have to deal with the DNS ownership.